Good morning, class 9th. Today we are going to travel further into our simultaneous equations. We had done a lot of problems in simultaneous equations. We had discussed three methods of solving simultaneous equations in my earlier lecture, in which we had said the first method was method of substitution, where we took the value of x or y from the first equation and substituted that value of x or y in the second equation and calculated the value of x and y. The second method was method of elimination, that in the two equations we made either x term equal. When I say x term, that means the coefficient of x were made equal by multiplying both equation or one equation depending upon the situation. Similarly, you could have made y terms equal also by the same method. And once we eliminate x, we get the value of y, or we eliminate y, get the value of x. That was the method of elimination. Third method was the method of cross multiplication, which I told you by making the matrix kind of a thing there. Now, another set of simultaneous equation questions we are going to discuss. Till now we had discussed in all the problems where x and y were mostly in numerator, never in denominator. But the problem which I am taking now today are the problems like this. 2 upon x plus 3 upon y is equal to 13. 5 upon x minus 4 upon y is equal to minus 2. These are the equations given to us, and we are supposed to find the value of x and y. Mostly I would be using the method of elimination in this. You can use any method, but I will be using method of elimination in this. Now here the x and y are in denominator. So what are we going to do? We are going to do that 1 upon x here also, 1 upon x here also, 1 upon y here also, 1 upon y here also. So we are going to substitute 1 upon x as a and 1 upon y as b, so that we get a and b in the numerator. Like if I put 1 upon x as a, I get 2a. Because you see, what is 2 upon x? 2 upon x is 2 into 1 upon x. So in place of 1 upon x, what am I substituting? I am putting the value a. So it becomes 2a. It becomes 2a. It is 3 upon y. I can write it as 3 into 1 upon y. And place of 1 upon y, I am writing b. So it becomes 3b. So here 2 upon x becomes 2a, 3 upon y becomes 3b is equal to 13. 5 upon x is 5a because 1 upon x is a and 1 upon y is b. So minus 4b is equal to minus 2, the fourth equation. Now these are two simultaneous equations which have taken another variable instead of x and y, a and b, but they are in terms of x and y. Finally we are going to calculate the value of x and y only. But we have, for our convenience, taken up something from denominator to numerator, because it is always easier when the terms are in numerator. So we have taken up in numerator and we got the value as 2a plus 3b is equal to 13, 5a minus 4b is equal to minus 2. These are equation 3 and 4. I have named them. Now I will eliminate a from this. For eliminating a, the coefficient of a is 2 here, the coefficient of a is 5. So LCM of 2 and 5 is 10. So I can convert this also to 10 and this also in 10. So I multiply equation 3 by 5 and equation 4 by 2. When I do this kind of multiplication, I get 5 2s are 10, 5 3s are 15, 5 13s are 65. And when I multiply it by 2, I get 2 5s are 10a, 2 4s are 8b, and 2 into minus 2 is minus 4. And then because 10a and 10a both are of the same sign, that is positive here, so what I need to do is to eliminate, I have to subtract. So I subtract equation 4 from equation 3. When I subtract this, 10a and 10a will cancel, 15b plus 8b, because it was minus, by subtraction the sign would change. It will become plus. 15b plus 8b becomes 23b. 65 plus 4 is 69. So 23b is equal to 69. b is equal to 69 upon 23. We get the value of b as 3. Now put the value, substitute or put the value of b is equal to 3 in equation 3. Equation 3 was 2a plus 3b is equal to 13. So in place of b, what I have done, I have replaced b by 3 because I have got the value of b as 3. So 2a plus 3 into 3, which will be 9, which will be transferred to right hand side. 13 minus 9, it will become 4. So 2a is equal to 4, or a will come out to be 2. So we have got the values of a and b. A has got 2, a is 2, b is 3. But we don't have to find the value of a and b. I have to find the value of x and y. We had assumed a to be 1 upon x. We had said a is equal to 1 upon x. So a is equal to 1 upon x is equal to 2 will imply x is equal to 1 upon 2. You just reverse the ratios. 1 upon x will become x and 2 will become 1 upon 2. Similarly, b is 1 upon y is equal to 3. So to find out the value of y, I must take y to the numerator. So I reverse the ratio. 1 upon y, I make it as y upon 1. So this 3 will become 1 upon 3. So the value of x is 1 upon 2 and the value of y is 1 upon 3. So your solution set is 1 upon 2, 1 upon 3. Please remember, I am writing this kind of braces because this represents that only members of this set are 1 upon 2 and 1 upon 3. This is a discrete set. This is a discrete set. Only 2 members are there. That means only x is equal to 1 upon 2 and y is equal to 1 upon 3 is the solution for this particular equation. Second question in this series is 2 upon x plus 5 upon y is equal to 1. First equation. 60 upon x minus 20 upon y is equal to 13. Second equation. Again, x and y both are in denominator. I told you in the first equation, whenever you come across such kind of questions, what you do is you substitute 1 upon x as a and 1 upon y as b. I explained it to you that 2 upon x means 2 into 1 upon x. So 2a I can substitute. Or 60 upon x is 60 into 1 upon x. So I can put it as 60a. That is what we have done exactly here. 2a plus 5b is equal to 1. 60a minus 20b is equal to 13. Now these are third and fourth equation. I name them something different. Third and fourth. Now I want to make either coefficient of a or coefficient of b. Either of the things. So I think that will be easier. I could have made for b also equal by multiplying the equation 3 by one number only. Here what I am doing is, this is 2a, this is 60, LCM is 60. So I will multiply this equation by 30. Equation 3 I multiply by 30. So 2a into 30 is 60a, 5b into 30 is 150b, and 1 into 30 is 30, and then we subtract because these two have the same signs. So for same sign, whenever the same signs are there, to eliminate we have to subtract. So we subtract this equation from this. 60a minus 60a will cancel. Minus 20b minus 150b will become minus 170. 13 minus 30 will give me minus 17. So b will become minus 17 upon minus 170. Minus minus will cancel and this will give you the value 1 upon 10. So I have got the value of b as 1 upon 10. I'll substitute the value of b 1 upon 10 either in equation 3 or in equation 4. I substitute this equation in equation 3. So 2a into 5b In place of b, I am putting 1 upon 10. So 5 2s are 10. It will become 1 upon 2. So 2a will be 1 minus 1 upon 2. 1 upon 2 from here shifted to right hand side will become minus 1 upon 2, and 1 minus half will be equal to half. So 2a is equal to half, a will be 1 upon 4. So you've got the value of a as I have written on the right side. A is 1 upon x. A was 1 upon x. So a is equal to 1 upon x, and the value is 1 upon 4. That will imply x is equal to 4 by reversing the numerator and denominator. Similarly, b was 1 upon y, and I had got the value of b as 1 upon 10. So 1 upon y is equal to 1 upon 10. That means y is equal to 10. That indicates that the solution set will be x is equal to 4 and y is equal to 10. If you substitute the value of x as 4 and y is 10 in these two equations, both the equations should be satisfied. What does it mean that both equations should be satisfied? If I put x is equal to 4 and y is equal to 10, so it will be what? If I put x is equal to 4, so 1 upon 2 plus 1 upon 2. 1 upon 2 plus 1 upon 2 will give you 1. So this equation is satisfied. Left hand side is equal to right hand side. If I put x is equal to 4 here, so 4 15s are 60. Here if I put 10, 10 2s are 20. So 4, how much? 15, because 4 was here, 4 15s are 60, and here it was 10, 10 2s are 20. So 15 minus 2 will be 13. So both the equations are satisfied. If you want to check your answer whether they are correct or not, you can substitute the value of x and y in equation 1 or in equation 2, and if the equations are satisfied, that means your answer is correct. That is the way of checking your answer also. Okay, the next question is 2 upon root x plus 3 upon root y is equal to 2. 4 upon root x minus 9 upon root y is equal to minus 1. We have to find the value of x and y. The only difference in this question is that instead of using x and y in the denominator, it is picking up root x and root y. Instead of x, he is writing root x. In place of root y, in place of y, he is using root y. Method will be the same. Instead of, we will say substitute 1 upon root x as a. We were saying 1 upon x is equal to a. Here we are saying 1 upon root x is equal to a, and 1 upon root y is equal to b. So when we put the value here, we get 2a plus 3b is equal to 2, and 4a minus 9b is equal to minus 1. I will make x terms equal by multiplying equation 3 by 2. If I multiply equation 3 by 2, I get 2 2s are 4a, 2 into 3 is 6b, 2 2s are 4, because I have multiplied the whole equation by 2. And then I subtract, because I have to eliminate. So 4a minus 4a will cancel, minus 9b minus 6b will be minus 15b is equal to minus 5, or b will be 1 upon 3. b will be 1 upon 3, because it will become minus 5 upon minus 15, and 5 will cancel, minus minus will cancel, and 5 3s are 15. Now put b is equal to 1 upon 3 in equation 3. Equation 3 is here 2a plus 3b. So 2a plus 3 into value of b is 1 upon 3. So it becomes 1. I'll transfer 1 to that side. It will become 2 minus 1 is 1. So 2a is equal to 1, or a will be 1 upon 2. Now look, a we calculated as 1 upon 2, and it was equal to 1 upon root x. That means root x is equal to 2. But I want to remove the root. For removing the root, we square both the sides. So x becomes equal to 4. Similarly, b calculated to be 1 upon 3. It was assumed to be 1 upon root y. So that means root y is equal to 3. And again we square to remove the square root. And we get y is equal to 9. So solution set is 4 and 9. In this question we have 5 upon x minus 1 plus 1 upon y minus 2 is equal to 2 first equation, 6 upon x minus 1 minus 3 upon y minus 2 is equal to 1 in the second equation. First we discussed when only x was in the numerator, x and y were in the denominator. Then we showed you a question with the root x and root y in the denominator. Now we are noticing x minus 1, y minus 2, y minus 2. And this method is only applicable when both the denominators are same. Like it is x minus 1, y minus 2, y minus 2. This method is only applicable then, because then only we can substitute. Like I am going to substitute 1 upon x minus 1 as a, 1 upon y minus 2 as b. So it will become 5a plus b is equal to 2. It will become 6a minus 3b is equal to 1. I can multiply the third equation by 3 to make b terms equal. I multiplied equation 3 by 3. So 3 5s are 15a, 3b it will become, and 3 2s are 6. 1. Now instead of subtracting I am adding. I told you because 1, here the coefficient of b is minus 3 and here the coefficient of b is plus 3. So they are of the opposite sign. If they were of the same sign, then I had to add the I had to subtract the two equations. But because they are of the opposite sign, we can subtract and cancel them. So we add these two equations. Minus 3b plus 3b will cancel. And what will you get? 6 plus 15 is 21a and 1 plus 6 is 7. So 21a is 7. So a will be 7 upon 21, which will give us 1 upon 3. Now we put 1 upon 3 in either 3 or 4. I have put 1 upon 3, a is equal to 1 upon 3 in equation 3. So 5a, 5 into 1 upon 3 plus b is equal to 2. Or b will be 2 minus 5 upon 3. We transferred 5 upon 3 to that side. So 2 minus 5 upon 3, it will become 1 upon 3. So the value of a is 1 upon 3. The value of b is also 1 upon 3. Now see, a was 1 upon x minus 1. A was substituted as in place of 1 upon x minus 1. So a is equal to 1 upon x minus 1 is equal to 1 upon 3. And we reverse the fraction. We get x minus 1 is equal to 3. Or from this we get x is equal to 4. B is equal to 1 upon y minus 2 is equal to 1 upon 3. We reverse the fraction again on both the side and we find y minus 2 is equal to 3 or y is equal to 5. So your solution set is x is equal to 4, y is equal to 5. So 4 and 5 is your solution set for this equation. The next question I have 1 upon 3x plus y plus 1 upon 3x minus y is equal to 3 upon 4. Second equation is 1 upon 2 into 3x plus y minus 1 upon 2. 3x minus y is equal to minus 1 upon 8. In the previous questions we dealt with when it was 1 upon x, 1 upon y. Then we dealt with 1 upon root x, 1 upon root y. Then we dealt with something else. And now I have 3x plus y and 3x minus y. 3x plus y, 3x minus y in the denominator. Method remains the same. 1 upon 3x plus y is common in both the first and the second. Put it equal to a. 1 upon 3x minus y is here also. 1 upon 3x minus y is here also. Put it equal to b. So in this equation, from this equation I get a plus b is equal to 3 upon 4. And when I take 4 to the side, it will become 4a plus 4b is equal to 3. That is equation 3. From the second equation, I get 1 upon 2a minus 1 upon 2b is equal to minus 1 upon 8. I take cross multiply 8 to this side, left side. So when I cross multiply, I will get 4a minus 4b is equal to minus 1. These are equation 3 and 4. If I add equation 3 and 4, because I can see it as 4b plus here and 4b minus here. If I add these two equations, 4b and 4b will eliminate and I'll get the equation in terms of A. So 8A will be 2, 8A will be 2 because 3 minus 1 is 2. So A will be 2 upon 8, which will be 1 upon 4. Once I get the value of A as 1 upon 4, I'm going to put A as 1 upon 4 in either equation 3 or in equation 4. So if I put it in equation 3, 4 into 1 upon 4 plus 4b is equal to 3, or 4b will be 2, so b will be 1 upon 2. Now see on the right side of the board, A is equal to 1 upon 3x plus y is equal to 1 upon 4. So that means 3x plus y will be 4, that will be fifth equation. I have b is equal to 1 upon 3x minus y is equal to 1 upon 2. That will give me 3x minus y is equal to 2, because when I reverse the equation, I'll get that. 3x minus, when I find the reciprocal or reverse, whatever you want to call it. So 3x minus y is equal to 2. Now I've got equation 5 and 6. Solve equation 5 and 6. Solve equation 5 and 6. I add 5th and 6th. I get to eliminate y. I get 6x is equal to 6. That gives me x is equal to 1. Then I put x is equal to 1 in equation 5 or in equation, whichever equation, I have put it in 6. So 3 into 1 is 3, minus y is equal to 2, or y will be 1 here also. So solution set is 1 and 1. The value of x is 1, the value of y is 1. I have a question where 7x minus 2y upon xy is equal to 5, 8x plus 7y upon xy is equal to 15. This is a little different, but we can change it to the same format. What we do is divide 7x by xy. If you divide 7x by xy, you will get 7 upon y. Minus 2y divided by xy will give you minus 2 upon x is equal to 5. 8x divided by xy will give you 8 upon y. 7y divided by xy will give you 7 upon x is equal to 15. Now we have got the same format of the equations which we have been dealing before this, 1 and 2, and we put 1 upon y as a and 1 upon x is equal to b. It is not necessary that you should always put 1 upon x as a. It is not necessary to use the alphabets a and b also. You can use any arbitrary alphabet u, v, p, l, q, r, whatever you want to use. We are using a and b. In this particular question, 1 upon y I have used as a, 1 upon x as b. So I get an equation 7a minus 2b is equal to 5, 8a plus 7b is equal to 15. Now in these two equations I'll make b terms equal, because for making b term equal I'll have to, I don't have to subtract, but I have to add. So what I do is multiply it by 7, multiply it by 2. When I multiply it by 7, 7 7s are 49, 7 2s are 14, 7 5s are 35. When I multiply it by 2, 2 8s are 16, 2 7s are 14, 2 15s are 30. And we add, because the b terms or the coefficient of b are of the opposite sign. One is minus 14, the other is plus 14. When we add them, b terms will cancel, 14b will cancel. 49 plus 16 is 65. 65a is equal to 65. A will be 65 upon 65. That will be 1. Once we have got the value of a, put a is equal to 1 in equation 3. You can put it in equation 4 also, that does not make any difference. 7 into 1 minus 2b is equal to 5. So minus 2b will be 5 minus 7, which is minus 2. Minus 2b is equal to minus 2, or b will be equal to 1. We have got the value of a as 1, we have got the value of b as 1. A was 1 upon y. So 1 upon y is equal to 1 means y is equal to 1. And b was 1 upon x. So 1 upon x is also, b is also 1. So 1 upon x is equal to 1 means x will be 1 as well. So the solution set for this pair of simultaneous equations is 1, 1. The value of x is 1, the value of y is 1. Next question in the series is 20 upon x plus 1 plus 4 upon y minus 1 is equal to 5. 10 upon x plus 1 minus 4 upon y minus 1 is equal to 1. I have discussed it from question number 1 to the question number 7 now we are at. That denominators have to be same, like it is x plus 1 here, x plus 1 here. It is y minus 1, y minus 1. Then only we can apply this method. Substitute 1 upon x plus 1 as a, 1 upon y minus 1 as b. It will become 2a plus 4b is equal to 5. 20a plus 4b is equal to 5. It will become 10a minus 4b is equal to 1. It will become equation 3 and 4. In equation 3 and 4, the coefficient of b are already same, 4. And both are of the opposite sign. So what we are going to do, we are going to add both the equation to eliminate the term y. When we have eliminated the term b by adding 3 and 4, I'll get the values of a. 20a plus 10a is equal to 30a is equal to 6, or a will be 1 upon 5. We have got the value of a as 1 upon 5. Put a is equal to 1 by 5 in equation 3. Equation 3 is 20a plus 4b is equal to 5. 20 into 1 upon 5, 5 4s are 20. 4b will be 5 minus 4 is equal to 1, or b will be 1 upon 4. So the value of a is 1 upon 5, the value of b is 1 upon 4. A is 1 upon 5, and we had assumed a to be, we had assumed 1 upon x plus 1 as a, so we'll write a is equal to 1 upon 5 is equal to 1 upon x plus 1. When we reverse or we find the reciprocal, we get x plus 1 is equal to 5. That means x will be 5 minus 1, that is 4. B is equal to 1 upon 4 is equal to 1 upon y plus 1. When we find the reciprocals, y plus 1 is equal to 4, or y will be equal to 3. We got the value of x and y. Now let us see what is the solution set is. X is 4 and y is 3. That is your answer. Okay, let's look into this question. 99x plus 101y is equal to 499xy. 101x plus 99y is equal to 501xy. This must trigger something in your memory, because this kind of question we have done earlier. It's also a special kind of simultaneous equation question in which we told you that first coefficient of x and y are quite large, like 99, 101. The other thing is that whatever is the coefficient of x in the first equation is coefficient of y in the second equation. 99x, 99y. The coefficient of y in the first equation, 101. Coefficient of x here, 101. So 101y, 101x. But one thing added. This side, on the right side, the numbers are quite large. 499xy, 501xy. In these kind of questions, we had told you there is a method which we follow, that once we will add both the equations 1 and 2, we'll get a smaller equation, and once we'll subtract equation 2 from 1 and we'll get another equation. For example, if I add 1 and 2, 99 plus 101, 101 plus 99, both will be same 200. 200x plus 200y. And when I'll add 499 and 501, I'll get 1000xy. 499 plus 1, 500, 500, 1000xy. Now what I do is, I divide the whole thing by 1000xy, left side. When I divide it by 1000xy, I get 1 upon 5y plus 1 upon 5x is equal to 1. I simplify it by doing 1 upon x plus 1 upon y, and 5 I take it to this side. I get equation 3. Now I subtract 2 from 1. When I subtract, obviously the difference of, as addition was same, subtraction will be same also. 99 minus 101 will give you minus 2x. 101y minus 99y will give you plus 2y is equal to minus 2xy, because this is bigger, minus 2xy. I divide the left hand side and right hand side by minus 2xy. When I divide it by minus 2xy, I get 1 upon y minus 1 upon x is equal to 1. I write first minus 1 upon x plus 1 upon y is equal to 1 is equal to 4, because 1 upon x should be on the same. The same variable should be in the beginning. Now, for example, put 1 upon x as a, 1 upon y as b. When we do that, we get a plus b is equal to 5 and minus a plus b is equal to 1. Let us add these two equations. A will cancel, you will get 2b is equal to 6, b is equal to 3. Once we have got b is equal to 3, let us put b is equal to 3 in equation 5 or in equation 6. I put it in equation 5, I get the value of a as 2. Once we have got the value of a and b, we had assumed 1 upon x as a, 1 upon x as a. We had said 1 upon x is equal to a. So a is equal to 1 upon x is equal to 2, or x will be 1 upon 2. We had assumed b is equal to 1 upon y, which is equal to 3. That will imply b is equal to 1 upon 3. So I've got the solution set as 1 upon 2, 1 upon 3.